How's it going, everyone? Welcome. Julio Gonzalez here again. And today, let's go into now continue to explore about this particular topic, especially on the JavaScript, which is speaking. And as a way to understand that, how do we get here and then finally move on to the chapter 2 of this book known as You Don't Know GS Yet, right? So the TLDR is that because this book is for those developers that are quite familiar with the language, that the idea here is to actually understand that how do we get here, right? From a more broad perspective and to understand a little bit of history up to this point is to see that this language that was made by Brendan H., a software developer that works at a company called now Netscape, the first browser or the first commercial browser at that moment, right? Where in 1996 they have now this language called Mocha as the code name that Brandon H made. They internally know this language as LiveScript, and the point of this is just to marketing this product as a lightweight alternative of the heavy but well-known Java language, where similar like Java in this particular language known as JavaScript, both of them are assumptions of the developers that must need to know, which is C language at that back then, and all of the concept around and how to use this particular language to build stuff. And all of this was a just an artifact of the marketing shenanigans, the name of JavaScript. But it turns out that this language that now is owned by Oracle via a series of acquisitions. So they went through first look at the Netscape that was acquired by AOL in November 1998, and then AOL was acquired by a company known as Microsums, and then Microsums was also acquired in 2009 in by Oracle, right? Actually, the European Commission raised a flag to see if there is no monopolistic practice, and they figuring out that no, there is an alternative database engines out there, not only those from Oracle, right? But there is Postgre or MySQL, and the language specifications and who are the responsible for defining the technical, hard, and quite verbose, but very specific details about how this language works is made by the TC39 commit, right? So they now follow is the spec from this standard, the ECMAScript 262, that they are the one who are responsible for improving the language. And no matter how you call this, whether it is JavaScript or ECMAScript or ES and the year of the specifications, at this point, Oracle has never enforced the trademark of the language, and quite frankly, is something that I don't think that this is going to happen, right? Now, this language specification, which are now developed by the TC39, which is a collective, a group of people that come from a diversity of web-related industries and companies, from browser makers, from device makers like Samsung, that they now bi-monthly they meet and they propose certain features, or aka champions, as I mentioned, to see how that can actually help the language as well as the web overall. So, because these proposals are now made by people that is in those particular come from those particular company, and some of them can receive some sort of compensation from that. All right, that despite that you and I or anybody can participate in the discussion, which is open. You can take a look now at a particular website called GitHub, which now has become a worldwide dominant place to host code. All right, whether it's private or public, even for open sources or closed sources code. But the point is that because the TC39 actually have a particular process that go from 0 to 4, because we as programmer we started to count from 0 to 4. This series of a stage that a champion, a proposal needs to go on. So those who make all the way up to the top, it's something that can take now weeks, months, or even years to reach to that place. So once a proposal reaches that place, now it's considered to be part of the spec. So because even though that most browsers now follow what the ECMAScript does, right, or mention, it's also true that not all browsers actually stick to the law, so to speaking, because one thing is that what the specification is, which is this is something that start way before and put in practice way before the spec has actually been considered something as a standard or applicable by a lot of developers as a standard, right? The idea here is to understand that some of these JavaScript interpreters or JavaScript engines now they decide to not implement some of those features because of the reality of the web. So this reality that it turns out that happens to a lot of funny questions and funny events, or some of them tragic and funny. All right. So one of them is, for example, when you want to identify if this element belongs to these collections of values, there is of course a word for that. Most of us say contains, right? But because that is something that was used by a particular framework that it was somewhat popular, right? And because the standard or the leitmotif, the motto from the TC39 is we don't want to break the web. So they have to actually rename that to now call includes. All right. And there is another things that is called the smooshgate, which is more tragic and comic. Okay, where again somewhat similar. We want is to, as a collection, flatten that. In other words, if you have a multi-dimensional collections, that most of the time, if you want to understand that briefly, is you say, hey, this multi-dimensional that, let's say you have now 3 axes, right? And then you want to convert all of them into one, okay? So if you want to flatten this, they want to implement this feature called flatten, but they also realize that there is a particularly framework out there that was using is this framework, all right? In some of those, in a decent amount of websites in Germany that not only they implement that, not only they take that name, but also is that implementations is doing some dumb operation as well. So it was quite involved in that regard. So what ended up happening is that, well, TC TC39 have to reverse that work, and they now propose is with the name of flat, right? So the idea is that despite that the TC39 actually make those strong statements that you must stick to the law, some of those JavaScript engines can decide to not to, and for those who do that, there's actually a particular appendix that describe in the spec what are the behaviors in details of when you have this particular mismatch. So talking about this mismatch is something that we as a developers, especially when you are new to this, and because we have now a collections of environments that we can run JavaScript, whether it's on the web or the server, as they mentioned, is light bulbs and robots, you name it. It is important to understand that the JavaScript code that we are running is going to be environment dependent. So for example, things like get current location or get user media or fetch is something that is quite specific to browsers. In the case of fetch, is also interchangeable with the server, right? And the same for the server. So you cannot read files on the browser. They are only relevant to that. And I mention this is because despite these huge collections of environments that we can run our code, all right, what the reality that matters is just the web. In practice, that's the reality that all matters, and that's what the ECMAScript actually followed, the web universe. So on that, and because here we can now write code to solve a specific problems in different style that the history of software engineering has now provided us, and say, hey, you know what, this is a series of a style that has seen, or we have seen, that are quite decent when it comes to build things at scale. So for example, we talk about is the procedural way of writing applications, or the opportunity class, where the idea here is to now defines or programs in data and in its logic in this unit calls now classes, and the other is the functions, where you want to define as a function, a pure function, a function that doesn't change the state of the application, all right? It's just going to compute that new state, and if you want to have new state from these results, aka derivative state, then you can now take that into consideration to generate now a new function for that. So all of this different particularly approach is just as a way to say, hey, you know what, this is how can we approach. So far it's not the only one, but this is how can we approach to problems and provide solutions on that. Now this is quite interesting, because when it comes to write your code, and then as you see that your code now provides some interactivity, or starting to build, or you starting to realize that you're building a lot of code here. So for example, if you're building now an interface to manage your crypto, if you're building now a SaaS application for your bank, or for your crypto, or for your social media So you're starting to realize is that this is becoming very huge, right? So because of this scale of code, we need to find ways to uh, understand how this code is executed so we can then optimize that. And this is why the question of is JavaScript and um, yeah, if JavaScript is an interpreter or compiler language, uh, comes here into place, because it is important to understand that the history of programming has to look, yeah, the history of programming has to look with disdain or with inferiority any interpreted language. Why is that? Because those languages are not that optimized for performance like a compiler, and they're no robust uh, because they're not statically typed. They don't have all of these type annotations on that. So what actually is it all that means here? Uh, it all means that a compiled language, which traditionally is going to now create is a it's going to take your source code, all right, this huge source code, no matter the length of that, it's going to take that, all right, and it's going to now convert into an abstract syntax tree. The process, the technical process of that is known as the compiler theory. Well, to put it simple is that it's going to read the entire code, all right, and it's going to tokenize that, which is the process of this is just to define by the language, all right, what are the units that make sense. You can think of this as what is the combination of word that we as human actually makes words, all right. So for example, not only words but then sentence. So this process of tokenization is some of what is doing is putting is having like all of these buckets, all right. And when the language particularly identify as a token that is or a reserved keyword or an identifier or a comment or an operator. So now it puts all of this into these particular buckets, all right? And once the process is done, then it's going to now construct is the internal representations of these buckets to actually see what is the structure of this. You can think of this like it is mapping, all right. So if you want to let's say you are now organizing a party, all right. So there are several stuff that you need to do. So you need to take care of the place, the lights, the perhaps the furnitures, or you also want to take care of the music as well and the beers if you want to drink some beer or not, because recently this is one of the things that I love of this new generation is that they're all actually too into drinks, and I find that's very interesting. Yep. But again, drinks over the history has worked like a social lubricant, so we can now open up to ourselves and discuss and love and have new kids and then regret from that and then have some AHV and then regret that and but the idea is that all of this series of steps that you need to do, right, is like a map, all right, and once you do that you can check all of them. So this is pretty much what it's doing with this internal representation, is that it has already now a way of understanding at the computer language how is this things looks like, all right. You have now a structure. It parses this by running is this and when it parses this is now taking all of this token and transform into these internal representations to syntactically check that everything is right. And this actually create now this abstract syntax tree, which is this internal representation that we're talking about. All right, you can think of this like uh, the the series of steps that you need to do, all right, to organize your party, and the things that you have to hold in your brain when you need to do that, right? So you need to hire a DJ, and then check the furnitures, and check who is gonna get invited to this party or not, and then manage or perhaps go out and annotate how many people are gonna attend to the event, and also buy some beers or some other foods, right? Some all of the other stuff that you need to as a way to organize a party. Now, this abstract syntax tree that the compiler actually does is then now generated a code that is these portable binary representations that can be distributed later on to be executed at that particular architecture. And this is just to describe is what a compiler language is. But I think this is something that is not describing or not looking at the essence of what the JavaScript is, if this is a compiler or if this is an interpreter, because you can boil down this into uh, the error mechanism and how now the language actually is checking those errors. So because of this, and because we also describe is how now a language, particularly interpreted languages, actually evaluate errors, is by the way you do that is, if you have now an error on line 5, if you have an interpreter, you need to evaluate line after the another, and then once you reach that, it can be a particularly syntax error, or it can be now a statement error, or it can be a value error, all right? Whereas unlike the compile, you don't have to wait for that to happen. You just actually take the entire program, and at the compilation phase or at the parsing phase, you can now detect those kind of errors, and then generate is the output that can be distributed across any other architecture there. So because of this, and since now JavaScript is a parse language, how can we know that? When you make a syntax error, JavaScript actually detect those errors first before even evaluating the code. This is why now JavaScript is, in essence, in practice perhaps, in not yeah, in essence, and maybe in practice, is that a language that is a parse language or a compile language. So this is the reason of understand why do we need to look at this, why we need to understand this, because when we now look at the flaws, so to speaking, or the concerns about languages, especially when you need to evaluate a huge collections of code, all right, a huge set of documents in your code. So you want to make that fast as much as possible, all right. So you want to make sure that the parsing or the compiler phase is fast enough, or is fast as much as possible, as well as the execution of this code. So there now has some attempt, for example, of the engineers at Mozilla in 2013, where they now build is this ASM, which is a subset of JavaScript that actually they were able to port is this language. Yeah, they were able to port is a Unreal 3D game from C to JavaScript to be executing on the browser at full 60 FPS. So this now show how now the language, by using is a small subset of uh, annotations that tells or that hints the compiler about to run some optimizations, is something that show off that decades, years later, with ASM, particularly the web assembly, that even though that is not meant to be written by developers, it's just like an intermediary layer to actually now target these languages and import that into a to be executed by JavaScript engine, which is in essence that what now the web assembly is assigned to. The WebAssembly now was designed to be the target compiler for any language, all right, that the output can be run in a JavaScript or in a WebAssembly environment, right? So you can think of this also that there are some efforts to look at the WebAssembly to be like this universal virtual machine, all right? But because this is not the entire goal of this course, it's just to briefly describe is what the WebAssembly is, and at least understand that it's not an intent to replace the JavaScript, despite that people actually have some ill will against the JavaScript, because again the historical versions of the language and how it's possible that JavaScript, an interpreted language, is now at this point. The thing here is that when it comes to understanding now how JavaScript actually process the code, this is what happens. So when your file leaves the code editors, it is now transpiled, and this transpilation is just also a way of how you can now guarantee that the JavaScript code is backward and forward compatibility, particularly backward compatibility, by letting the JavaScript developers, which is also something that is promoted by the community, hey, use the latest syntax of the JavaScript, while we or the particular tools, this transpiler, are going to be responsible for adding some behaviors when that particular feature doesn't exist, or shims, aka polyfills, right? So transpiler like Barrel or also TypeScript, actually they are the one who are now shipping or who are transpiling that code, which is now take the, let's say you are now writing code in let's say you are writing code in the 2024 spec, right? So you can indicate what is the target that you want to transpile your code, and the target can be, for example, ES 2019, and that is something that is widely executed or approved by a lot of this JavaScript engine out there. And then this particular process of transpiling, right, is also bundled up using a particular model bundler, right, that is ready to be shipped to a JavaScript engine. So the JavaScript engine now take that code, all right, and then parse that, creating the abstract syntax tree. And this abstract syntax tree is now generates an intermediary binary representation known as the bytecode, okay, that the compiler that it leave inside of the JavaScript engines is going to run some optimizations or refinements in this just-in-time compiler, uh, and then once that is done, now that will be executed by the engine, by the JavaScript virtual machine, right? This is the process that happens when you now write code until it's get delivered uh, to be served by somebody in on the world, right? And this is also a topic when it comes to write your code, especially the strict mode, that this is something that is important to understand, because now, for example, you can see that the relationship of frameworks like uh, React or Next that is using now this particular directive, like use client or use server, and the same is for use strict, where the point of this is to use now this particularly or follow this particularly is guidelines that the use strict enforce us as a way to write code that is much more performant and easy to read, to avoid some of the common gotchas and errors that happen. One and silly example, all right? One and silly example is that when you define now, for example, this. So when you define now, um, um, of course, most of us will not read this kind of code, all right? But this is something that is valid, and we want to prevent this kind of error by using is now the use strict for that, right? So the idea here is to understand that use strict is something that is now used by default, especially if you're working with ES models, and then, well, let's go now to define is the TL, the air of all of this. So JavaScript is an implementation of the ECMAScript, which is the standard, all right, which is guided by the TC39 and hosted by ECMA, all right. It runs in browsers and other JavaScript environments such as server, and JavaScript is a multi-paradigm language that gives us the capability to combine those styles, whether it's object programming, procedural, and functional programming, where now JavaScript is a parsing / compile language, meaning the tools, including the JavaScript engine, process and verify the program first for early detection, okay, before it executed. So with our language now defined, let's start getting to know the ins and outs out of this. That's exactly what we signed for. That's exactly what we signed for. After 33 minutes talking about this topic, I think that is important for us to move on to the next topic. Okay. Okay. Now, let's move on with this. Chapter 2. What is the chapter 2 means here? Serving. Okay, serving. Strictly speaking. And then define. So on define here, we talk that. So JavaScript is a compiled language. Is this one, right? Now, all right, good. So chapter 2, here we are. Here we are. Chapter 2 is about each file is a program, values, declaring and using variables, functions, comparison, how we organize in JavaScript, and the rabbit hole deepen. And then digging to the root of JavaScript, iteration, closure, this keyword, prototype, and asking why, and the bigger picture, which is what this core or this book is all about. Is the scope, the prototypes. We went through the types and coercion, all right. But I want to actually dive deep into the scope and the closure. But for that, let's go into now quickly read about this to understand that a little bit more, right? Shall we? Good. Now, so the best way to learn JavaScript is to start writing JavaScript. To do that, you need to know how the language works, and that's what we'll focus on here. Even if you're programming in other language before, take your time getting comfortable with JavaScript and make sure to practice each piece. So this chapter is not an exhaustive reference on every bit of syntax of the language. It is also not intended to be a complete intro to JS primer. Instead, we're just going to survey some of the major topic area of the language. Our goal is to get better feel for it so that we can move forward writing our own programs with more confidence. We'll revisit many of these topics in successively more detail as we go through the rest of this book and the rest of this series. Please don't expect this chapter to be a quick read. It is long and plenty of detail to chew on it. Take your time. Alright. Okay. Okay. Plenty of detail. It is a long, there is a plenty of detail to chew on. Tip, if you're still getting familiar with JavaScript, I suggest you reserve plenty of extra time to work through this chapter. Take each section and pondering and explore the topic for a while. Look through existing JavaScript programs and compare what you see in there to the code and explanations and opinions, of course, present here. You will get a lot of more out of the rest of the book and series with a solid foundation of JavaScript Nation. Alright, and there are several topics here. And this was not to be intended to be read fast. Alright? It is a long it is a long read, and there is a plenty of detail to chew on. Y hay muchos detalles para masticar. Hay muchos detalles para masticar. Okay, there is a plenty of detail to chew on. All right. So you got now this. Each file is a program, values, declaring and using variables, functions, comparisons, how we organize in JavaScript, the rabbit hole deepens. But let's take a look at this topic. Okay. So each file is a program. Almost every website, web application you use is comprised of many different JavaScript files, typically with the .js file extensions. It is tempting to think of the whole thing, the application, as one program. But the reality is different. But JavaScript sees it's different. In JavaScript, each standalone file is its own separate program. The reason this matters is primarily around error handling. As we mentioned before in the parsing section, since JavaScript treats files as programs, one file may fail during parts of compile or execution, and that will not necessarily prevent the next file from being processed. Obviously, if your application depends on 5 of JavaScript files and one of them fail, the overall application will probably only partially operate at best. It is important to ensure that each file works properly and that whatever extent possible they handle failures in other files as gratefully as possible. It may surprise you consider a separate JavaScript file as a separate JavaScript programs. From the perspective of your usage of an application, it is sure seems like a one big program. Exactly. But that's because the execution of the applications allow these individual programs to cooperate and act as one program. By doing this chunk or by bundling up, right? Many projects use build process tools that end combining separate files into the project into one single to be delivered to the web page. And when this happens, JavaScript treats this single combined file as the entire program. But usually and sometimes you have now chunk of JavaScript and these files, each file is a program, and it is primarily around the error handling. So the only way multiple standalone JavaScript files act as a single program is by sharing their state and access to the public functionality via the global scope. They mix together in this global scope namespace, so at runtime they act as a whole. The only way multiple standalone files act as a single program is by sharing their state and access to their public functionality via the global scope. They mix together in this global scope namespace, so at runtime they act as a whole. Since ES6 JavaScript also has supported a module format in addition to the typical standalone JavaScript program format, has also supported a module format in addition to the typical standalone JavaScript program format. Modules are also file-based. If a file is loaded via module loading mechanism, such as import statement or a script type module tag, so modules are also file-based. If a file is loaded via module loading mechanism, such as an import statement or a script type module tag, all of its code is treated as a single model, aka as a single file, aka as a single program, aka the JavaScript engine is going to parse that individually. And the only way multiple standalone JavaScript files act as a single program is by sharing their state via the global scope. Okay, as long as they have this, if they share the global scope, this is now the way of how multiple JavaScript files can act as a single program. Interesting. They mix together in this global scope namespace, so at runtime they act as a whole. Alright, if a file, exactly, since ES6 also, JS has also supported a module format in addition to the typical standalone JavaScript program formats. Modules are also file-based. If a file is loaded via module loading mechanisms such as import or script type models, but if a file is loaded via this if a file is loaded via this module loading mechanism, whether it's import or script type models, all the code is treated as a single model, as a single program. A file or a program that is going to be parsed for errors, for syntax errors. Though you wouldn't typically think about a model, a collection of a state and publicly exposed methods to operate on that state. As a standalone program, JavaScript does in fact still treat each model separately, similarly to how global scope allows standard standalone files to mix together at runtime. Similar to how global scope allows standalone file to mix together at runtime. Importing a model into another allows runtime's interoperations between them. Regardless of which co-organization patterns and loading mechanism is used for a file, standalone or model you should still think of each file as its own mini program, which may then cooperate with the other mini programs to perform the functions of your overall application. Values. The most fundamental unit of information in a program is value. Values are, but the whole point of this is that it's describing that each file, each file is a program. Okay. So this section is just to describe topic that are relevant to JavaScript developers. The JavaScript developers to be more to understand, to write our programs with more confidence. To write our programs with more confidence. Yep, that's right. With more confidence. Absolutely. We'll revisit many of these topics in successively more detail as you go through the rest of this book and the series and the rest of the series. Please don't expect this chapter to be a quick read. Exactly. And please don't expect to this chapter to be a quick read, right? There is a lot of details to chew on, and one of them is each file is a program. All right, each file is a program. So in JavaScript, every file is a program, and the question is that exactly. So in JavaScript, every file is a program. Since our web apps, we can think of this. You use is compressed of many different JavaScript files. Exactly. Since our web app use several and sometimes compress, but most of the time several and compress JavaScript files. Okay. It is tempting to think of that as one program. The whole as one program. But JavaScript see it differently. Okay? But JavaScript see it differently. So in JavaScript, every program, since JavaScript, every program is a or every file is a program. All right. The reason this matter is the reason of this is primarily in how JavaScript. The reason of this is primarily. The reason of this is primarily how JavaScript handles errors around error handling. Since JavaScript treats files as programs, one file may fail during parse and compile or execution of this is primarily around error handling. Since each file is a program, one program that fail can won't interrupt the execution of another program. That's interesting. So you can say is now serve to content, and I would like to actually do a code pen for this because I'm not sure if I can actually send several content here. I'm not sure if I can send several content here. But that's interesting. But I know that that's interesting. Can I add another resource here? Your website, for example, and doing something like this? Exactly. jQuery, Lodash, React, Angular, Vue, Ember. But it makes a lot of sense. By the time that the browser read these JavaScript files, all right, they act like a program, which has its own separate programs, and the reason of that is around the error handling. So if one program, and it makes a lot of sense, so if one program fails at compile or parsing or compile phase, or during the execution phase, it will not necessarily prevent the next file from being processing. So one program that failed will interrupt the execution of another program, which is a desired behavior, as you can think of this. All right? It is a desire. So obviously, if your program is obviously if your program is something if your program now depends on other programs to be executed, you and one of them fails, at best you can expect that your web app doesn't behave normally. All right? Or there's some missing behaviors there. You know, there's some missing behaviors there. Exactly. So at best you can expect that your web app will partially at best you can expect that your web app will partially that your web app will partially operate. It is important to ensure that each file works properly and that whatever extent possible they handle failure in other files as grateful as possible. So it may surprise you to consider separate JavaScript files as separate JavaScript programs from the perspective of your usage of an application. It is sure seems like one big program, and that's because the execution of the applications allow these individual programs to cooperate and act as one program. Okay, exactly. But at the end of the day, all of those programs, all of those files are programs. And this is primarily around the error handling. Because if one file fails during the parsing or the execution, it won't prevent from other files to be executed, right? Unless that some of your files are dependent, right? And at best, what you can hope is that your web app will partially operate. Okay. That's quite interesting and counterintuitive, bro. Absolutely. 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 So that's because the execution of an application allows these individual programs to cooperate and act as one. Okay? So from the perspective of your usage of an application, it is sure seems like one program. So for the application usage, from the point of view POV of application usage, you can think that this is that act as a one big program. But the reality is that all of those files are collaborating. That's so interesting. All of those files are collaborating to produce all of exactly to produce the whole web app experience. Or act as one, exactly. A whole web app experience. That's interesting in terms of experience and all that kind of stuff. That's very, very interesting. Very, 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 very interesting. Very, very interesting. Absolutely, bro. Absolutely. However, the only way a program can act as a standalone, all right, if that is the only way multiple standalone JavaScript files act as a single program, or the only way, okay, the only way multiple programs act as a standalone, except multiple program acts as a standalone app, all right, the only way multiple standalone files, the only way multiple standalone files act as one, all right, or act as a single program, as a single program, is if they share their state in the global namespace. So if they actually share the state in the global namespace, right? Then this is the only way that those programs those standalone programs can act as a single one, because they're sharing that state. Oh, interesting. Via the global scope. And access to their public functionality. It shared their state. It shared their state. Okay. And access to their public functionality. And access to their public functionality via the global scope. Via the global scope. Interesting. All right. Holy fuck. So they mix together in this global namespace at runtime. So they mix together at this global scope. So they mix together at this global. So they mix together with the global scope in the global scope at runtime. Interesting. It's like, hey, all of this now are sharing its state with the global space or via their public functionality. So they becomes now they became, so all of these standalone files, they became now one single program, because they share their state. Holy fuck. Okay. So if once they share their state, they become now a single program. So if they share their states, or that's interesting. If they share their states, or they now is, if they share their states, or if they share their states, all right, or they access to the global space. All right. Now all of those standalone programs at runtime act as as a single program. That this is also part of the graph theory here. Interesting. If all of them are connected via their state, now that's right. They become now a single program. But by default, if they're not, they now are single standalone programs, which is and it is doing this, and it is this interesting, and it is this because around the error handling. All right. So each files now act as these standalone programs that if they fail, pretty much like the processes in your OS. So if one misbehaved process fail, it won't interrupt the another, right? However, if those programs they are interconnected, all right. If one of these programs depend on another file, all right, exactly. If one of those programs depend on another file, at best you can hope that your web application will partially operate. Mm-hmm. 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 So that's the only way that these standalone programs can now act as a single program if they share their state. Uh, exactly, if they share their state or access their public interface via the global namespace. Okay, so they mix all of these standalone programs in the global namespace at runtime. So EX6, which is the new way of how you can work, not that new, or since EX6, exactly, since EX6, each file, or you can write, also support model format in addition to the typical standalone. So JavaScript also support models in additional to standalone. All right. In addition to standalone. Interesting. In addition to standalone. To typical standalone. In addition to standalone programs. Right? So models are also files based. So when you use an import, right, or when you load a file via import or using the script tag, say type model, that's interesting. All right, and the closing tag is here, right? All it is code is treated as a single model. So all it is code is treated treated as a single file. Though you wouldn't typically think about a model a collection of states and publicly exposed method to operate on that state as a standalone program. JavaScript does, in fact, still treat each model separately, similar to how global scope allows standalone files to mix together at runtime. Importing a model into another allows runtime's interoperation between them. Okay. So similar. So similar to how global scope allows standalone file. Exactly. Similar to how global scope allows standalone files to be act as a single program by sharing the state or access. Okay, by sharing the state. Because it's a collection of state and publicly exposed methods to operate on that state as a standalone program. JavaScript does, in fact, still treat a collection of state and publicly exposed methods to operate on that state. Similar to how global scope allows standalone files to act as a single program. Alright. And to mix together, exactly. By mixing together at runtime, importing a model into another, importing a model into another allows runtime interoperation between them. Allows runtime interoperation between them. Damn, son. Fuck that shit. Regardless of which co-organization pattern and loading mechanism it is used for a file, standalone or model, you should still think of each file as its own mini program, which may then cooperate with one mini program to perform the functional of your overall application. Regardless how you or regardless which co-organization is used for a file, regardless how co-organization, whether it's a file and loading, okay, regardless of which co-organization pattern and loading mechanism is used for a file, whether it's a standalone or model, okay, regardless of how co-organizations patterns and loading mechanisms is used for a file, okay, it is still important to understand you must think, because this is not a should, you must think of your program, because there is no should, bro. It is or not. You must think of your program, or you can think of your program. All right, you can think of your program. So you can think of each file as its own mini so you can think of so you can still think of each file as a mini program that collaborate with another mini program to perform the function of your overall application, to perform your program, or to perform the function of your application, to perform the function of your overall application, okay, of your overall app here. But again, you can think of this single files or single programs as mini programs that they are cooperating or collaborating. All right. Okay. You can still think of each file as a mini program that may cooperate with another program to perform functions of your overall app. That is quite interesting. That is mind-bending, bro. That is mind-bending stuff, bro. That is definitely mind-bending stuff. Definitely mind-bending stuff. And that'll be all for this video. Take care. Bye-bye.